All right, let me share my screen. You guys can see my screen? Okay, so let's just talk about the agenda of this course and why we are here and what I'm going to cover and how it can help anyone who's going to be a part of this course. So this is my second batch. Okay, my another batch is already running. It's in the middle, and I mean I have six people there in that batch. So yeah, so it's the second batch. So this is something new that I've started. Yeah, so let's start with the course curriculum first. So okay, first of all, this course is for people who are looking to change their job into either Linux administration, systems administration, the cloud engineer roles, cloud administrator, or if you have something like container engineer, or Kubernetes engineer, or in general, if I talk about DevOps and SRE roles. Okay, so this course is going to help anyone who wants to switch their job into any of these domains, any of these roles. So this course will be more focused on the interview preparation. Okay, so I mean whatever I have learned to crack an interview for a DevOps or SRE role. So same I'm going to follow here. And as you can see on the screen, the course is going to be including all these things. So I'll start with some of the fundamentals of DevOps in this session itself. And I'll start with the very basics of Linux because Linux is going to be the base of everything that we're going to do. Okay, so some people say that you don't need to learn Linux to be a DevOps engineer, but that's absolutely wrong. You need to be really good with Linux administration to be able to work in your day-to-day tasks. Okay, once you land the job, and also I'm going to cover AWS cloud. So anyone who is targeting cloud roles as well. So all the the core services are going to be part of this course. Then I'm going to talk about containers as well. So in containers we have various these different container runtimes. We have Docker, we have Containerd, we have Cryo, and there are some other platforms as well. But yeah, so we'll talk about it. And then after this, I'm going to cover container orchestration, which is a way by which you can manage hundreds and thousands of containers in an efficient way, and you can efficiently, monitor the status of the containers and do a lot of things. Okay, so there are a lot of features in container orchestration platform like Kubernetes. So we'll talk about that. Then I'm going to cover source code management. So I'll be taking Git based approach, which is the uh, most popular approach to manage a source code for the applications. And I'm going to use GitLab as a source code management tool here. We do have other platforms as well, but GitLab is one of the most popular tools in the modern DevOps era, I would say. And for a CI also, we have various platforms. So I'll cover CI part as well, and I'm going to cover a GitLab CI in this course, and then I'm going to move towards CD part, which is the continuous delivery or deployment part. So for that, we'll be using Argo CD in this tool. And here comes this monitoring part, which is the most crucial part if you're targeting SRE roles, especially. So there I'm going to cover Prometheus and Grafana, and I'm going to cover some shell scripting projects as well. And then in terms of infrastructure as code, I'll be covering Terraform, and then we'll just move on to some real world scenarios or the projects for interview preparation. And yeah, I'm going to cover some interview question and answers, and will also help you in resume building. Okay, so I'll just close this, and let's just talk about some of the fundamentals of DevOps, okay, which are really important. So in this session I just want to cover that. And yes, then you can decide whether you want to be part of the course or not. So first thing is, what is DevOps? Okay, in general, if I say, like, why companies want to adopt this approach, or companies are adopting this approach, why everyone wants to learn DevOps, and why there are so many opportunities in this domain. Okay, so we should know the core concepts. So just on a very high level, theoretically, if you want to understand, so there are two words, okay, DevOps, which means development operations. It basically means that you have some set of modern tools and technologies and methods and practices that you can use to deploy an application for a customer in a better way. Because we have other ways as well which you can use, but DevOps is one of the ways which is getting really popular to deliver an application to a customer in general, if I talk about. Okay, so we use a set of tools, technologies to deliver applications to customer in a certain way. Some call it a specific culture also that a company or an organization adopts, where all teams they work in a collaborative manner to deliver applications to their customers or the end users. So basically, I'm talking about uh, the development team who's going to write the application source code, and you will have some IT ops team which is going to work together to deploy a particular product for the customer. Okay, so why this, I mean, DevOps term is there because they all work like a single team. Okay, what used to happen previously that the development team is working on something and they will not let any other team know what they're doing, and suddenly after like 2-3 weeks they will say, okay, I mean, I have developed this application, now please deploy it. So the other team have no idea what the developer is doing, and when they are, I mean, deploying it to the this to any dev environment in cloud or any other environment, in that case that application is going to fail in most cases because the IT ops team is not aware of what they are doing, and there's no communication between the two teams. So in this DevOps approach, these two teams are continuously talking to each other on day-to-day basis so that they can share the inputs which are required to deploy a particular product or an application in a better way, in a way wherein they both can agree to it, and it's going to help the overall application delivery as well. Okay, so in general, that's that is what is called DevOps. Okay, so once again, another question is why we need it, why we need DevOps. So to improve application delivery, to find an effective and an efficient way to deliver an application from a developer's laptop to the customer or to the end user. Okay, so once again, as I mentioned, we have, I mean, many ways to deliver an application to a customer. It is just that we want some way by which we can have a good quality product delivered to the customer in the best possible way in less time. Okay, with uh, uh, less errors. So all that is part of your DevOps uh, work culture. Okay, in general, if I talk about, so to automate the day-to-day tasks. So this is one of the most important things that the DevOps engineer does. They are able to automate a lot of manual tasks, which are error prone, which are not that efficient, which takes a lot of time. So all that is part of the DevOps work, and that's why this approach is really getting popular. A lot of companies want to adopt the DevOps approach to deliver their applications. Okay, to be able to automate a lot of the manual tasks that the people were doing before DevOps, to reduce the time of the entire SDLC or software development lifecycle. It's the same thing. Means the developer is going to write the code on his or her local laptop. The code is going to move to a repository. From there, it's going to be deployed to a server. Then that piece of application or code is going to be tested thoroughly, and then after the tests have passed, only then the application will be promoted to the other I mean higher environments like test, UAT, or prod. Okay, after all the tests have been done in the low environment. So this is how it happens. So to reduce the time of the entire SDLC life cycle, we use DevOps. And also, as I mentioned, while being able to reduce the time, we are uh, not losing anything on the product quality part. So we are still able to maintain high quality product or the application for the customer, okay, without, I mean, wasting any time, without wasting anything. So this is the main thing that we have to take care of when we are working in a DevOps environment. And also one of the most important things as a DevOps engineer is to be able to continually monitor for any errors that still may arise, because I mean, not everything is perfect. So I mean, whatever work you do, whatever automation you do, that is still prone to errors, but yes, the number of errors are going to be relatively less as compared to when you do things manually. So being able to uh, 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 continually monitor for any errors or issues that arise while doing any of the work related to DevOps, and being able to proactively troubleshoot the issues as well. So all this is part of your DevOps approach. Okay, so now let's talk about how the application used to be deployed when there was no DevOps. Okay, so that's also important, and how DevOps is able to help us with you know do uh, what it is supposed to do. So in general, I'm talking about a time where I think it's around 2007 or 2008. Okay, just before that time, the applications were being deployed in a certain way, which was not that efficient. So at that time, what used to happen? The application developer is going to write the code on his or her laptop. Okay, the application developer, once the code is written, he is going to push the code to a remote repository, a source code repository, where he or she can store all the application source code. At the same time, the application developer is going to inform a person who's going to be a systems administrator, who's going to check the requirements of the application and configure a server on which the application can be deployed. So the systems administrator is going to create a server depending on what the application needs. For example, if it's a Python based application, so of course you should have the Python runtime installed on this server. Along with that, whatever other dependencies are there for the application, and in terms of the resources that the application is going to use in terms of CPU, memory, okay, then network bandwidth, storage, your storage performance, all that is going to be considered, and the systems administrator is going to create a server for the developer so that the application can be deployed on this. At the same time, once the code is pushed to the source code repository, then at that time, there was another person which was called a build and release engineer. So build and release engineer is going to take the code from the source code repository, and he's going to try to deploy this code to the server. Okay, and once the code is deployed to the server, then another person called tester is going to test the application. So he's going to perform some tests manually on this application that has been deployed, and he's going to share the results with all the stakeholders which are relevant to this application. And once the application is able to successfully pass the tests, okay, so just one more thing, that it always starts with a lower environment like a dev environment. So in companies you have a different set of environments. You have dev, stage, UAT, prod, like that. It depends from one company to the other, or one project to the other, what type of environments you have. But in general, you will at least have three environments. Okay, dev, QA, and prod. So dev is used to develop the application. QA is used to thoroughly test the application. And then after all the tests have passed, only then the application will be deployed to the production environment. So suppose this is the dev environment where the application is deployed first. So after the tests have succeeded, only then this application is going to be promoted to the higher environment, which is going to be either QA, or it can be some other as well. But in general, I'm talking about. So it's going to be dev, QA, and prod. So from dev, the application will be promoted to QA environment, and then after successful tests in QA, the application will be deployed to uh, production environment. Now this is okay, but what if the tests fail in the dev environment itself? So at that time, we did not have the concept of something called as microservices. Now, if I talk about this microservices concept, it's a way by which you can decouple the components of an entire application stack. In general, on a very high level, if I talk about, suppose you have a three-tier application, which means that you have a front end, which is going to be a web server like Apache or Nginx, whatever front end component you're using, you can use. You also have a backend of the application. So the web server or the front end component of the application needs to talk to the backend. And then you also have a database layer, which is storing all your database that is being generated by your application. So your backend is going to talk to the database. So you have these three tiers of the application. So at that time when we did not have DevOps, what used to happen? The entire source code will be in one single file, which means that all the three components will have the same code base. So this is not a good practice. Why it is not a good practice? Because this developer has been working on this code for many weeks. So at that time, this entire cycle was used to be like 3 weeks or so, which is a very big cycle. Considering today's world. Okay, so time is money in today's world. So at that time, this entire cycle was used to be like 3 weeks or so. So after 3 weeks of development, when the code was uh, deployed first on this server, the code fails, for example. So then this has to do a lot of debugging. Okay, and this code may be like I think 500 lines of code. Since there was no decoupling, there were no microservices concept. So the entire application stack has just one code base, and now you have to debug the application. So it used to take a lot of time. Had there been an approach where the developer can continually test any piece of code that is deploying, like 10 pieces of code that he has developed or written, he can test it then and there, it would have been really easier for him to identify the bug or fix the issue then and there. But at that time, this was the way that things were moving. Also, if you see, creation of the server or deployment of the code is all manual. Even the testing is being done manually. So all these things are only going to increase your SDLC time. Okay, the entire life cycle time is going to be increased. It is prone to errors. Okay, so it's not that efficient approach. It's not that efficient approach. So how uh, DevOps is able to help us is by building something called as a deployment pipeline. So now what we can do is we still have these people available, like we still have systems administrator, we still have testers, we still have the build and release engineers. In general, these build and release engineers are the DevOps engineers of today's world. But the the thing is, they do not have to deploy the application manually each time. The developer has pushed any changes to the source code of the application, but these people can build a pipeline which all these stages, okay, so all these stages can be automated. And once the once I mean if there are any errors in the pipeline, only in those cases they have to look into the issues. So it's going to save a lot of time and effort of all these people, and it's going to reduce the time, and it's going to increase the quality of the product also, because when you have these processes automated, it's going to be resulting in a less number of errors also. So this is how the DevOps approach is going to help us by building a pipeline where you can automate all these different stages, and you can still uh, deploy the code to all the environments. So all these things can be automated in today's world. So if I talk about some of the benefits of DevOps in general, so it is to automate tasks. Okay, whatever things I just spoke about, you can automate all these tasks as a DevOps engineer. You can improve the application quality. You can do continuous monitoring. You can do continuous testing, and it's going to decrease your software development lifecycle time. So this is why we all want to learn DevOps. We want to move DevOps. Why companies want to adopt DevOps approach, because it is more efficient in every way possible. Okay. Yeah. So this is all I wanted to cover as part of the demo session. Yes, yes, yes. So in today's world, we all create these CI/CD pipelines. You are right. Continuous integration, continuous delivery, or continuous deployment pipelines for the applications. So in this way, you are able to automate all the tasks. So where I'm working right now, we have the pipelines for each application. So we do not have to do these things manually now. We have built a pipeline. Only when any errors arise in the pipeline, we have to troubleshoot the issues. Else we just have to monitor the status of the pipelines. So in this way, we are able to reduce a lot of errors. We are able to continually monitor. Also, we have tools like Prometheus and Grafana that we're using to monitor the application. We create the alerts, we create the dashboards. The custom dashboards are there, custom alerts are there, depending on application developers' requirements. So all that is being done in today's world as part of the DevOps and SRE roles. Uh, uh, it's a very good question. Okay, some people think that DevOps means only containerized applications, only microservices, but that's not true. We still have some applications that actually run better in a monolithic way also, and we have some legacy applications which are really hard to containerize also. So uh, those applications have been kept as it is, but all the modern day applications are being containerized in general. If I talk about where I'm working right now, I have some applications that have been deployed directly on the EC2 instances, and these are some really old legacy application, and nobody wants to touch them because trying to containerize the application can actually break the application, and it can impact the customer in certain ways. So they don't want to take any chances. The applications are running fine, but all the new applications are being containerized mostly. So yeah, that's all I wanted to cover as part of the demo session. If you have any questions, you can let me know. If not, I'm going to close out the session, and you can share the feedback. And if you're interested, just let me know. I can share the details of how you can enroll to the course.